Alright, well thanks for coming. Today we are talking about SolidWorks versus Composer, the age-old debate. So hopefully as we go through this webinar today, I'll be explaining a little bit of the way I see the comparison between these two products, at least where some of their perceived overlapping occurs. So let's get right into it and see what we can accomplish here. So my agenda for today is to kind of compare these two tools, again, where they sort of overlap. So we're going to explore what tools SolidWorks has available for the purpose of documentation, creating images, that kind of thing. We're going to take a look at what tools Composer has available, and we're going to kind of compare the two of those and see where those overlaps occur and where each of those tools fall in terms of strengths. In my opinion, there are very clear sets of examples of when I would use Composer versus SolidWorks and vice versa for different purposes. So hopefully I can outline that a little bit for you today and clarify some things. So this webinar is kind of being spawned from this question, which I seem to get asked a bit because there are some overlaps between the two products. So, why do I need Composer? I can get a screenshot, I can get an animation from SolidWorks. This seems to be a product that doesn't really have a place. It's already, the functionality already exists in other software that I own. Why would I possibly need Composer if I can already get done, what I need to get done? And again, that's a question that I get asked a lot, and hopefully as we go on through this webinar this morning, I'll be able to explain to you what the differences are between those tools, and again, why I use each when I do. So today on Therapist Jesse, we're talking about communication. So that's my focus on that side of SolidWorks. I'm not really focusing too much on the actual modeling side. Obviously, SolidWorks is the tool for modeling. Composer doesn't really overlap in that arena. So Composer is focused towards communicating and getting our point from the engineers to whoever it needs to go to. And that can be a variety of different people, right? We can be sending that just internally. So maybe we're sending assembly instructions to our own guys on the floor who are picking those up and assembling maybe their instructions for new hires or people who are relatively new to the job and need to pick up how a process works. Or it could be the other way around, where we're sending this kind of stuff out to our customers who are completely unfamiliar with our product or potentially unfamiliar with our product, and we need to express something to them that would be, in terms of geometry and CAD, how things will go together, come apart, what they need to do, how they need to use our product. So communication is definitely vital to internal as well as external, and we need to make sure that we're being as effective as we can just to avoid mistakes on our own part and mistakes by our customers. Clarity is never a bad thing. So that's what I'm going to be focusing on. How effective are we at communicating using these two different sets of tools and what they offer. So what I want to ask is kind of how do we share? So Benjamin Franklin, we all know Benjamin Franklin, made famous by his invention of Netflix. That's not true, I made that up. But he must have done something right because he got his face stuck on money, and that's always a good thing. So he said something to this effect. He said, tell me and I'll forget, show me and I might remember, and involve me and I'll learn. And I think this is kind of the point that I'm going to be driving home. I know this is absolutely 100% true for me. As I'm talking to somebody, if we talk about something, chances are I'm going to forget. I've got a terrible memory. Some of you know this about me. I can't remember your names to save my life, right? I have a terrible memory if we're just talking about it. But if I see it in front of me, I'm more of a visual learner, and I think a lot of us are that way. If we can see it, we've got a picture to associate. There's more bits of information that we have a chance of hanging on to. We're taking that information in on more senses than just one. So seeing something, showing someone something, that can definitely lead to better retention. And I find that, you know, you go on YouTube and watch a video, hopefully from the CAD Dimensions YouTube channel, but you go on YouTube, you watch a video on how to do something, and it makes a whole lot more sense than reading a page of text, at least for a lot of people, right? Reading a page of text, we can figure that out and have a better shot of remembering that. But even better, if we can get in there and get our hands on something, figure out how that works, try it for ourselves. I know for me personally, that's when I really learn it. That's when I know it, and I can internalize that. So I'm going to kind of be running with that theme as we go and just kind of comparing these two tools and what they offer. So starting off with SolidWorks, because again, SolidWorks, coming back to the main question that I get asked, why is Composer here when SolidWorks offers everything that Composer can do? And I'm going to make the case that that isn't true, but let's take a look at what SolidWorks can do and what it does really well. And some of the things that SolidWorks can offer us are the creation of shaded raster images. All right, so that's our first one. I'm going to be talking about the different types of graphics as we go through this, so don't worry about that right yet, but just a raster image would be, think of a JPEG, right? A bunch of little dots that's creating an image. We can get that out of SolidWorks with not too much trouble, right? We can save as JPEG, save as PNG, right, if we're in 2014. We can get that stuff out fairly easily. So that is a format that SolidWorks will offer us. Animations, of course, we can do animations in SolidWorks. We have the motion animator that we can use to create fairly complex animations. And we'll see a little bit of overlap between these two tools, but we can definitely do animations in SolidWorks, and we can use that as an output, you know, AVI or whatever the case is. Another tool that SolidWorks offers us in this arena is photo-rendered images and animations. So that is, you know, via the help of an add-in that would be PhotoView 360, and we'll take a look at that again in a little bit as well. This is one of the cool strengths with SolidWorks. If you've got that add-in, you have the ability to photo render images, which will give you a different type of quality that you won't see with any other type of image. And we'll talk about the differences between those. So in terms of output, we're looking at a SolidWorks file, right? We can communicate SolidWorks data with a SolidWorks file. If somebody has SolidWorks itself, right, if our customer has SolidWorks itself, or if the guys on the floor have SolidWorks, a seat of SolidWorks, they can open up a SolidWorks file and we can communicate through that file, of course, right? They can look at the data, they can take their measurements. If it's a SolidWorks drawing, we can communicate those dimensions displayed in kind of a 2D format. But of course, we can take SolidWorks and ship that to somebody who has SolidWorks and communicate that way. It's a very effective way of communicating, of course, but we can't really add too much to it other than here's the model, this is what it looks like, figure it out. E-drawings is another way that we can communicate with SolidWorks, right? We can take a SolidWorks file, SolidWorks drawing, whatever the case is, we can send that to someone who has an e-drawings viewer and they can view that file, take a look at it. You know, we have the opportunity to send some information that way, even if they don't have SolidWorks. So that's a possibility in terms of communicating through SolidWorks. Now, a couple of those options, those first two options, may or may not be great if you know, we don't want people getting access to all of our actual engineering data. Right? There's stuff in there that we may or may not want our customers poking around in there, and chances are they're not going to want to go download e-drawings or find e-drawings or happen to have SolidWorks for them to receive that data. So oftentimes, while that's a possibility, it's not likely. So we can share SolidWorks data also with images. I mentioned that that's one of our tools that we've got available to us. Raster images, we can send those out, save them as a JPEG, ship it to somebody and say, here's a pretty picture of what I've done. Does this make sense, yes or no? But we really only have the ability to just save that picture, and unless we have some other type of tool to make any markups or anything like that, we're really just kind of stuck with, here's a picture, hope you know what it means. Videos is another option. I mentioned that with SolidWorks we can save those animations that we've created out as a video, as an AVI file, and send that to somebody. and they can watch through a video and see something happening. Okay, so we're getting closer to show me and I'll remember kind of thing, right? If I can watch something sort of happening, I'm thinking, okay, I'm more understanding how this works, unless it's, you know, saved in some kind of view where I can't really see, something's obscured. If I have a question, I can't do anything about it. All I have is just watch the video and hope it explains what I need it to explain. Nevertheless, that is a pretty good way to communicate with people, and that you can show something actually in motion in the environment that it needs to be in, and that's a pretty good way to communicate many times. So SolidWorks seems like it's got an awful lot to offer in terms of being able to take that engineering data that we've created and communicate that to somebody else, right? Through a drawing, through a SolidWorks file, whatever we seem to have multiple outlets. So where on earth does Composer really come into this if SolidWorks has so many cool tools to help us in this area? Well, let's take a look at what we have. So to begin with, we see shaded raster images as one of our outputs, and we think, well, we've already got that covered, so scratch that off. That can't be useful. But I'll make an argument for that a little bit later. That is one of the overlaps. So we can of course save out as a JPEG. It would be suspiciously missing if it wasn't part of the Composer tool set that we could use. So Composer can of course save raster images. However, the next one down is kind of an interesting one, and that's vector images. And I'll go into an explanation real quick. Hopefully I won't bore you completely to death of what the differences are between raster and vector. If you don't know, I do get that question quite a bit, so hopefully I can clear that up for you. But we've got animations as well in Composer, so seemingly overlapping here. We've got some animation capability that Composer offers. However, the second one down, so 2 and 4, are kind of unique. Interactive content is an interesting one that we have available to us with the Composer toolset, and I see that as one of the real valuable tools that Composer allows us access to. So if we kind of compare these apples to apples, again, Composer has, in terms of output, sort of a similar, parallel output. So of course we can use a Composer file. So just as you can send your SolidWorks file to somebody who's got SolidWorks, we can do exactly the same with the Composer file. We can send our Composer file out to somebody else who has Composer, and they can open that up and take a look at whatever we've got saved in there. And that can be a perfectly acceptable way to communicate through our Composer output. But again, they've got to have Composer in order to read that, or they have to have Composer Player. So Composer Player, think of that kind of as the sister product to eDrawings, right? That's kind of the viewer for our Composer files. Okay, so that's a great option. We can use our viewer to pull information out of a Composer file that is saved into that file, again, without having Composer on that machine. We can email that software, they can open that up, take a look at what's inside of there, and hopefully that will explain what's going on. A paper document, of course, that's pretty common, right? Where the Composer product was designed initially to meet that need. You know, we're all still making actual physical documents in terms of PDFs or actually printed out that have images depicting what needs to happen. It's a great way to get things down on paper, no pun intended, and send that out for somebody to pick up, look at, and figure out, right? We can take a piece of paper anywhere with us. We don't need to have any access to electricity even to figure out what needs to happen. I did make a note here that in the paper document we can use raster or vector images, and again, that's just foreshadowing for what I'll talk about in a minute. But also, we have video output from Composer, so if you're expecting animations, you're expecting a video output that goes alongside of that. So that makes sense that we would be able to save that out, again, in AVI format or something like that. But we still have this guy kind of looming here at the bottom, which is this published interactive content. And there's a myriad of different ways that we can get this interactive content out to our users. We can embed that player in a PDF. We can drop it, on an internet site, or however we want to send this out. There's a bunch of different ways that we can get this information that's in a Composer document out to our end users, to our guys on the floor, whoever that ends up being. And again, this is the thing that I really see as an awesome advantage with using Composer, aside from what else we'll talk about here. So let's kind of look side by side here and see what actually stacks up, because again, coming back to kind of what prompted this, and that was if SolidWorks has these options, why do I need Composer? And if we lay these side by side and just kind of boil this down to its most basic state, we have Composer offering raster images, vector images, animation, interactive content, where SolidWorks is offering us our raster image and animations. And if we take a look at that, we see right there, yep, there is definitely overlap between these two products, in that they both offer output for raster images and animations, videos of some sort. Composer is gaining the edge here in the technical sense, documentation sense, with having vector images and interactive content. Okay, so those two things right off the bat, Composer does have over SolidWorks in the documentation and communication arena. And I'm going to talk a little bit more in just a moment here about why and when you would use Composer versus SolidWorks for these similar outputs. Because though they do share the same outputs in these two raster images and animations, I would use these two products in different scenarios depending on what result I'm looking for. So let's keep moving. So let's talk about graphics real quick. I said that I would explain the difference between a raster and vector, just so we're all on the same page. And a raster is an image that is made up entirely of pixels. This is pretty much everything that we get our hands on the web, or what we save or create. If we take an image with a camera, it's just a bunch of little dots that show up on a page when we look at it kind of cross-eyed, right, or at a high enough resolution that our mind is able to blend these together. It looks like an image. So we can see that the image on the left-hand side is all pixelated. Okay, and that pixelation occurs from that rasterization of the image, where it really is only just a bunch of dots that make up the image. I'm sure that we've all come into this situation where we find an image on the web, or we create an image and then we go to make it the size that we actually want to make it, and we find out that it's completely fuzzy. It looks like it's out of focus, and we can't even see what the heck is going on. Alright, so this is a real problem. That's the main limitation of raster images. Once it's saved at a resolution, there's really nothing you can do to change it. You can resample the image, but it basically just uses algorithms to try to guess at what the original resolution was, or try to get up to a higher resolution. There's really nothing you can do to improve that quality. So this is where the vector file comes in very handy. And a vector file is not made up of just little points that your eye just blends together to look like an image. A vector file is made up of entirely shapes. So we see that in this case we have the letters showing up as nice and crisp. Okay, and we could see this level of detail at any size. Okay, so that's the beauty of a vector. It's fully scalable. I can make these two letters the size of a wall, and I could have these created at the same quality as they are showing on my screen right now, or the size of the thumbtack. Alright, it's actual shapes, so I can make those shapes bigger, I can make those shapes smaller, and I'm not going to change the quality of that image at all. Okay, so vector files have that unique advantage over control over quality, which is very handy, and something that a lot of people really seek to have because it gives them flexibility down the road. In fact, the images that are on the CAD Dimensions PowerPoint template that you see here, these were created in Composer using this vector output. So I created these using the vector output, and then I ended up converting them to raster images once I got them at the quality that I needed them for the template. So vectors can be a very handy tool, and again, that's only offered in Composer. So if vectors are so awesome, why don't we just use them all the time? If they're completely flexible in terms of quality and size, why don't we just always use vectors? And that's really the wishful thinking of it. We would like a photorealistic vector of whatever we want, because that would give us essentially a realistic image of whatever we need, and we could make it any size we want, at any time we want it, at any quality we wanted it, and be able to create that image. And this, this combination of a photorealistic and a vector would be the ideal combination of formats. If we could get this consistently and quickly, this would be the be-all end-all to, well, at least in my humble opinion, to the graphics industry. This is what we would use as a standard instead of something, say, like a JPEG, which is very common today. Because we could create photorealism with it, we could go anywhere from shaded to something that looks like it was created with a camera. And we would also have that scalable output that goes along with that. So why don't we do this? If we take a look at this image here, you're going to have to put up with my Motorhead side here for a moment. This image looks pretty good. At least I think it looks pretty good. Aside from the fact that the bike looks awesome, this image looks pretty much like it was taken with a camera, but it wasn't. This is actually a vector image that has been created entirely by shapes. So if we take a look at how this was made, this is the problem with photorealistic vectors. So this was drawn entirely by hand. I presume it took 37 weeks to generate this. All of these individual shapes, I mean, you can see everything in here. Every little shape, every little gradient was generated by hand. Sure, we could try to create an algorithm that would try to generate this, but you give me a call when you've got it created. This is very difficult to do. Okay, so each one of these little shapes, if I flip back here, creates one of these gradients. All right, so this is painstaking work. So though it is ideal, it's really not a reality that we can use. So that is why raster images are so popular. We can view them very easily. Just about anything can read a raster image, and we just have to be very careful about what quality we actually save things in. So let's talk a little bit more about raster images, since they seem to be fairly mainstream these days and probably will be for quite some time. And let's talk about shaded versus rendered raster images. All right, so what we're talking about here is entirely just made up of little dots, no vectors for the moment. There are two real types, at least in the CAD world, of raster images that we can create. So if we look at something like a shaded raster, and I'll give you a visual of this because if I show you, you might remember. A shaded raster image supports things that we're used to seeing right out of the CAD software. So we've got, shaded with or without edges. You can use your real view, turn on shadows, ambient occlusion, all that kind of stuff. And you can save that out, and the JPEG will reflect that, right? If you turn on your shadows and your real view and you save out that JPEG, you'll see that in the actual image. Ambient occlusion would actually be an exception to that, but if you did a screen grab, say, you could get ambient occlusion saved into a raster image, again, all just represented by dots. Now, a rendered image, while you end up with the same result, it is just a series of dots, could be even at the same resolution, is created from your model, from a 3D model, by using ray tracing. So what that means is that the software, in this case PhotoView 360, is tracing all of these light beams around your scene, whatever you've got set up in terms of lights and environments and stuff like that, and it's figuring out how that would react in a natural environment. Okay, and don't ask me how they program that. I have no idea, but it works very well in SolidWorks, and it's fairly easy to use, and it's one of the great benefits of using SolidWorks for this kind of thing. However, when we're using our rendered images, this does require more setup time. We've got to kind of tell this, tell our CAD model how things should look in real life. It requires a bit more input from us as we're creating these things, because we've got to figure out how our reflections, we would expect those to look. You know, any refractions through transparent objects. How our lighting needs to be set up, where we want our lights, how the environment looks, our bump mapping. All of these things are things that we have to keep track of. So rendered images always look awesome when they're set up right. And if they're done well, you can't even tell the difference between a rendered CAD model and an actual photograph, right, when they're done well. But that takes a lot of effort. Okay, so there are two different types of raster images that we'll end up seeing here as we kind of look at this comparison. For example, here is a model. I downloaded this model and just kind of threw some textures on it. Told you I was a gearhead, sorry. Here we have just kind of a screenshot of a SolidWorks shaded model. So this is kind of how you would expect to see it if you've got some appearances thrown on in SolidWorks. I've got a camera turned on here, so we kind of see some exaggerated lines, but for the most part, it doesn't really look like I took this with a picture. We can fairly easily figure out that this is a model of some sort. Images in the background, these textures are just images, so those look a little bit more realistic. But the model itself, we can fairly easily pick out that it isn't real life. But as we go through adding effects in to our CAD model, and again, this could apply to Composer or to SolidWorks. I happen to grab these out of SolidWorks. We can get different styles of images. Now again, the format is the same, they're just shaded differently. So I've got real view turned on here in this case, just bumping up with shadows, adding a little bit of realism each time. Ambient occlusion bumped on, so we get a little bit of extra darkness in the areas where it's surrounded by geometry. All right, but until we get to something that's actually rendered, all right, so this is just an image that I created using PhotoView 360. This looks a little bit more convincing, right? This, if you looked quick, you might think is a photograph, all right? Now more work could be done here, but the point is that there are two distinct types of those raster images, and SolidWorks with PhotoView 360 offers this type. So if we combine all of this, what this really comes down to is which tool is right for the job, right? And this is kind of where we started off to begin with. So I've got a few different items across the top here. We've got shaded raster images, vector animations, photorealism, and interactive 3D. So in looking at this, we can just kind of start from the left and work our way across. With our shaded raster images, my choice for creation of shaded raster images is Composer. Yes, we can do this in SolidWorks, and this is one of the areas that we saw. They do actually overlap, right? With those shaded raster images, we can create a JPEG in both. My choice is Composer. And the reason that I choose Composer to create these is one, ease of creation. In Composer, I can just set things where I want and create a view. Where in SolidWorks, I have to either save a view and save a configuration, or maybe a display state or something like that, to try to capture all of the information that I need. I need to be able to save physically where the components are. I need to be able to save where the camera is. I need to be able to save their colors and so on and so forth. Where I have to manually save all of that information in SolidWorks, Composer does all that for me automatically. As soon as I hit to generate a new view, it's saving all of that stuff for me automatically. So number one, ease of use. I can just get all of that kind of for free. Number two is huge, and that's why I put it in capitals. Updates, 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 updates. Nothing ever stays the same once we start a design process, right? You've never started a design process. You draw it up once and then nothing ever changes again. Of course not. That's not how the design process ever works. So Composer allows us to update that and keep all of the information that we already had before. So if there's a physical change through engineering, we can handle that by just updating our Composer document, which updates all of those views. Everything that can be saved is saved, and I don't have to do any rework. If I'm doing this in SolidWorks, of course the geometry updates because we changed it manually in SolidWorks, but I have to go back and I've got to save out all of these images again. I've got to make sure my display states were right, all my colors and all that were right. I have to go back into every camera view and save those all out manually as JPEGs again, overwrite the files. All of that is taken care of for me in Composer. So if there's any iterations down the line, Composer really starts to jump ahead in terms of speed in creation. So it's faster to create them and it's faster to recreate them, if you will, in Composer. So those two factors add to why I choose Composer for this update, for this category. And storage, I just like the way that Composer stores my views. That's kind of a personal preference, but again, I can kind of see everything just outright. Composer was built for this specifically, so it's got an edge in that case. For vector images, the next category over, of course I choose Composer because SolidWorks doesn't offer that output. So if I want a vector image created from my model, I either have to A, draw it by hand, or B, generate it in Composer. This can literally save you weeks worth of work if you do need vector outputs. I've talked with people who do draw these by hand, and then they need to change things by 15 degrees and they have to redraw the whole thing by hand. Click of a button in Composer will solve that, and I've seen people fall off their chairs in looking for that. So vector images, Composer is the only way to go there. Animations is the middle category here, and I've kind of got a tie on this one, Composer / SolidWorks. These two tools I would use in different situations, and this is where I kind of feel that I owe an explanation here. So I use Composer, my note says everything other than mechanical, and what I mean by that is that if we're creating something in terms of animation which is reliant on motion that's created by mates, I will definitely do that in SolidWorks. I still find that to be the easiest track. We can always fake things in Composer, but if we've already generated the mates and we have the option to check that out in SolidWorks, I would do that in SolidWorks, and I would still do that in SolidWorks. You know, until further changes are made with Composer. However, everything else I will do in Composer. Composer is far quicker, in my opinion, in terms of animation. Because of the way they've set up their timeline, it's much more efficient in getting you where you need to go quickly, and therefore I will choose Composer to animate anything unless it has specific motion in it, or the next category applies, and that is photorealism. So with SolidWorks, we get the awesome benefit of having access to PhotoView 360, which can be really, really cool. Composer doesn't offer renderings. We can make marketing images in Composer by just adjusting the render settings, lighting, you know, all of that. But we have no capability to do full photo rendering. And that is something that SolidWorks can offer. So if we're looking for that out of an image or out of an animation, SolidWorks will be your tool for that type of thing. And that works very well. Again, that will also require more setup time, so there's a trade-off there. And the last column is interactive 3D, and again, Composer is the only tool that offers that output. So we're left with Composer on that as my choice for that one as well. And that, again, I want to reiterate, is where I see Composer having the real advantage. All right, well, I've been bending your guys' ears for quite a bit now, so let's take a look at some of these things, just visually take a look at them, some of the examples of things we've been talking about here. So so I just talked about the interactive stuff being, in my opinion, one of the coolest things that we have as an offering from the Composer side. So here's an example, and if you've ever talked to me about Composer, which I'm sure many of you have, I've probably showed you this model before because I think it's one of the coolest techniques out there for using interactive content in Composer. Now, interactive content with Composer has a wide variety of things that we can do with it. I mean, we can go from just a simple animation that's got links to the next steps or to certain steps in that, to linked geometry, linked views, so that we can kind of string someone along in a certain process and show them in order how things have to happen. This technique in particular is a little more free-form, and it kind of fits itself more to the direction of involve me and I'll learn kind of an idea. And what I've done in this model is set things up so that the user has what they think is free reign. They can explore this model by just clicking on whatever icon we have available here, and I can change things a little bit. But whatever they do, the model seems to just react to them. Okay, so if they click on things, things come apart, things go together. And whatever we do here, things just seem like we can explore as much as we want. And really, again, I've set kind of a framework in this model for what reacts to what, but giving your user, whoever you're trying to communicate with, the opportunity to explore how something might go together or come apart, or just how things fit in their own way. They can look at things, they can explore, they can see exactly what they need to see when they need to see it. We're involving them in that model, and again, I think that gives us more of an opportunity to communicate more clearly, because they can see things the way they need to see things. And again, hopefully they'll retain that information better if they can experience it themselves. So again, there's a lot that we can do with interactive content, from animations to just simply doing bill of materials where things highlight indicating what's what. There's a lot that we can do with the interactive side of content that I think kind of gets forgotten a little bit with Composer. But I also compared the simpler things that would be 2D images, and I still picked Composer over SolidWorks for a lot of those things. So let's take a look at that real quick. So I have just another example here, simple little RC truck. You may have seen this model kicking around one of their example files for 3D Via. And one of the coolest tools that I think, in my opinion, we have in Composer, for efficiency's sake anyway, would be this guy over here, the multiple tab in the high resolution image workshop. And what that allows us to do is say save all of our views. So that takes everything that's over here that I've created for this document already, and it saves those out with a standard naming convention, or file name _ view name. And by keeping that, what that allows me to do is update that in the future. So if there are changes to the model, remember that these views will update to reflect that because of the way that Composer works. And I can use this multiple view tab here to save those back out. And if those files are linked and embedded in my document, those changes are automatically made. And what I mean by that is if I hit Save As, we can see that I have these already saved in here. So I'll just create these over the top. I'll just overwrite them. All right, and when these save out, they're saving in just a folder that I've created for these. So when I switch over to a document here, I just have a silly little example document. But what we can do is take this document and insert some of the pictures for this. So this would be text describing what's happening here around these images. We can pick some images to work with in this document. And what we want to do would be insert and link. Adobe products do this automatically, but with Word, we want to insert and link, and what that means is that it's going to bring the document, bring the image into the document, but it's also looking back to where this image came from, so that if any changes are made to that JPEG file, then that will be reflected in the Word document. Now this is pretty powerful, especially given the way that Composer works, because if we create this document, somewhere partway along this process, we can have these images as sort of placeholders, if you will, that are just continually getting updated along the process. So if I come back to my composer file, and we'll just make a simple change. I think I put in view 4 here. So view 4, this could be a model change. This could be just a change in the way I want to view things. Let's just turn the opacity down on this body. So we'll make the body a little more clear, and we'll update that view. As soon as that view is updated, I can save out all of my views again. Just one click, right? We can run through that, and all of the views are saved. So whatever changes I made as I've been working through Composer, again, if that's a model update, if that's just more work that I've done, any of the images that I've dropped into my document already will update. Let's compare this with SolidWorks, where if we've got if we've got a model here in SolidWorks, we can create these views. We can save views, right? If I use my spacebar, we can save some views out, and those views can be saved. Those views can even be saved across SolidWorks, but I don't have any way to really store these things conveniently. I've got to save these images out by hand, or I've got to either save those views or add cameras to store those views. Then I've got to pay attention to my configurations to make sure my model is physically viewing the way that I want it to. We've got to consider all of those mates. Maybe we're using display states for that. All of those things have to work together in order to get the right image out of SolidWorks. So yes, we can create the same or similar images through SolidWorks, but if anything changes, those updates are a much more laborious project, because we've got to go back through and make all those changes ourselves. So what we're left with using SolidWorks as a technical documentation tool is usually just waiting until the end of the design process and then trying to generate that content. So with Composer, we can get that that jump start on the process and really move things along a little bit more quickly. Alright, so to wrap this up a little bit, again with comparison, back to Ben Franklin, which tool is better for communication? If I tell you, all I really need is a megaphone, my big mouth, to try to get my point across, but oftentimes that's not all that successful. I can show you with either tool. This can be either one. It can come down to a preference, or it can come down to what your end goal really is. But we can, of course, get images and animations out of SolidWorks. So it's possible to use this as a documentation tool for sure. Composer definitely falls into this category because that's what it was designed to do. But either of these tools could be used to show somebody. But to involve you, I feel like that Composer is really the only option there. So if we kind of translate that a little bit, if I tell you, we might forget. If I show you, might remember. But if I involve you, then we're learning together. So I feel that Composer does have that edge there. So with that, I'll wrap this up, and hopefully I've cleared up some of those differences between SolidWorks and Composer, and now we know exactly when to use each tool and what those strengths really are on both sides of the table. And thanks for showing up today. So if you guys have any questions, let me know. I'll check them out in the bar on the side. Thanks.